So what we're going to be doing in this video is we're going to be looking at two search algorithms. The first one is a linear search, which is also called a sequential search. It examines all values in an array until it finds a match or reaches the end. The number of visits for a linear search of an array of n elements, the average search visits are n divided by 2 elements, and the maximum number of visits is n. So a linear search locates a value in an array in big O notation of n steps. So again, the book has provided the linear search method that you can go ahead and execute. But what I'm going to be doing mostly is I am going to focus on the binary search. So a binary search locates a value in a sorted array by determining whether the value occurs in the first or second half of the array, and then it repeats the search in one of the halves. The size of the search is cut in half with each step. So the one thing in a binary search is that the array must be sorted before you can go ahead and run a binary search. In a sequential search, the array does not have to be sorted. So basically what it does, searching for 15 in this array, the last value in the first half is 9. So the middle element, so what we can do is we can just focus our search on positions 5 through 9. The middle element of this sequence is 20, so the value must be in either 5 or 6. The last value of the first half of this very short sequence of 12. This is smaller than the value that we are searching, so we must look at the second half. 15 is not equal to 17, so we don't have a match in this case. So what I've done is I've gone ahead and I've actually created another class. So let me go back into JGrasp and find my search, my binary search. And what you can do again with this method or with this class is you can do a Control-A, Control-C, and then you could drop it into the Java visualizer tool. So let me go ahead, click on Edit Code, and we will drop it in the tool. And we will go ahead and visualize execution. So again, what you can do is you can start working forward. So what we've done, we've created the array. Our value that we're searching for is 25, so I'll click on forward. We're going to call our binary search function what we pass in the array, the minimum index or the first location, and then the size or the last location, in this case 9, which is the last position in our array. Then we're going to check is low less than or equal to high. It is not, or it is. So what we're going to do is we're going to go ahead and set our midpoint equal to the low plus the high divided by 2. So that's 9 divided by 2. That's our midpoint is 4. And then we'll click on forward. So if the value at our midpoint equals the value, we'll return the mid. If not, we're going to check to see if our midpoint A4 is less than our value. Our midpoint is 15. It is less than the value, so what we're going to do is we're going to call the binary search again, passing it in a new midpoint of mid plus 1, so the mid will be 5, the high will still be 9. So we're going to check to see if our low is less than our high. It is. We'll go in we'll define a new midpoint, which is just 14 divided by 2, which will be 7. So if A at our position 7 is equal to our value, with 25 is equal to 25, so what will happen is we'll return 7. And then what we're going to do after that, we'll click on forward. Our position is now equal to 7. If our position is equal to -1, we'll print out the value was not found. If it's not, we'll go ahead and print out the place where it was actually found. So what we're going to do next then, what you can do is you can go ahead and edit the code and then put in a value that's not in the array, and then you can walk through the visualizer tool to see additionally how that binary search works. So a binary search, you count the number of visits to search a sorted array of size n. So what we're doing here is we're going through and we're actually determining what the big O notation is. So a binary search locates a value in a sorted array in a log n steps. So should we sort an array before searching? If you're searching the array only once, a linear search is more efficient. If you will make many searches, it's worthwhile to sort and use the binary search. So what I'm going to do is I'm just going to scroll through the next section, which is sorting and searching in the Java library. So you do not need to write sorting and searching algorithms. You can go ahead and use methods in the arrays and collection classes. The arrays class contains a static sort method. So to sort an array of integers, you would just go ahead and pass in that array into the sort method. And the sort method uses the quicksort algorithm. If you have an array list, you would go ahead and use the collection sort. The collection sorts uses the merge sort algorithm. And then arrays and collection classes contain static binary search methods. So if the element is not found, what gets returned is -k -1, where k is the position before where the element should be inserted. So in this case, 7 is not in our array, but it should be inserted before position 2. So what will get returned is k, which is a -2, -1, which is a -3. So v should be inserted before position number 2 in this case. And then they go into comparing objects. You can go ahead and work through that on your own. So that's all that I wanted to cover about search, the various search algorithms, both the linear search and the binary search. So that's all I have for this video. So we will talk to you next time.